Given fx equals to modulus 2x minus 1 and gx equals to x plus 4. First question, write fx as a piecewise function, hence find the function hx equals to 2fx plus 3gx. Okay, so let's do for it first. So write down fx as a piecewise function, which is mean fx equals to absolute value of 2x minus 1. Then we can define this as piecewise. 1 for 2x minus 1, where 2x minus 1 is greater than or equals to 0, and another one is negative 2x minus 1 for 2x minus 1 less than 0. Okay. So let us simplify a bit for the intervals. So 2x minus 1 for x is greater than or equals to 1 over 2. We bring this negative 1 here and divide with 2. So we're going to get x greater than or equals to 1 over 2. And we can expand this if you want. If you don't want, we just write down as negative 2x minus 1. So I'm going to expand a bit. Negative 2x plus 1 for x is less than. Do the same as just now. So x is less than 1 over 2. So this is the piecewise function. Hence, find the function hx equals to 2fx plus 3gx. 2fx plus 3gx. Okay, so we know that our functions fx is a piecewise now. Okay, so we may times 2 each of the function, okay, and plus with 3gx. Okay, so this is g, so you're gonna multiply this g with 3. Okay, so then let us write down as a piecewise function. So there is 2 here, so let's highlight a bit. Okay, so 2 will times with the first one, 2x minus 1 plus, and there is 3, which is going to multiply with gx. So plus 3 times g. Gx is x plus 4. Okay, x plus 4. G times with x plus 4, and the intervals will be follow with x greater than 1 over 2, and do the same thing for the x less than 1 over 2. So 2 times negative 2x plus 1 plus with 3x plus 4 for x less than 1 over 2. So simplify. So let us expand this. Let's do the first line first. Okay, expand. 2 times 2x, which is 4x. Negative 1 times 2 is negative 2. 3 times x is 3x plus 3 times 4 is 12. For x is greater than or equals to 1 over 2. And let us expand for the second line. So 2 times negative 2x is negative 4x. 2 times 1 is 2. And same goes as for this one. It becomes 3x plus 12. For x less than 1 over 2. Let us simplify some more. So 4x plus 3x is 7x. Negative 2 plus 12 is positive 10 for x greater than or equals to 1 over 2. Negative 4x plus 3x is negative x. 2 times plus 12 is 14. For x is less than 1 over 2. Okay, so this is our hx. Okay, so I'm going to put hx at each of the lines as h is the functions. Okay, next what we should do is sketch the graph of h. Okay, so sketch the graph of h. Now let's draw the graph. X, this is y. When x is 0, y is 10. So 2, 4, 6, 8, 10. Okay, somewhere here. When y is 0, x is negative 10 over 7. Somewhere here. Okay, and for x is more than or equals to 1 over 2, so if there is this 1 over 2 somewhere about here. Okay, so let us substitute 1 over 2 here. So 7 when x equals to 1 over 2, y equals to 7 times with 1 over 2 plus 10 is 13.5, right? So this is 12, 14, so 13 over 5 is somewhere about here. So this is 13 over 13.5, right? Somewhere here. So the graph will be greater than or equals to 1 over 2. So it's going somewhere about here. Okay, so I'm gonna just draw a line. So you're not sure where your graph gonna look like, so maybe you like to find another point. X equals to 1. So if x equals to 1, then we're gonna get 17. Ooh, okay, let's bring up some graph up here. And 17 is somewhere around here. 14, 16, 18, 17, somewhere here. Okay, somewhere here. Okay, so if we connect the lines, it's gonna look like this. So let's draw. Okay, and another one for x is less than 1 over 2. When x is 0, y is 14. 14 is somewhere about here. Okay, and let us find some points. Okay, when x 0, at 0, no, when x is 1 over 2, y is 13.5, but when you can connect these two lines, actually we don't have to find another point, I guess. Okay, so we just can do like this. The shape is not symmetrical, of course. Okay, somehow you're gonna do like this. Okay, so that's the graph. Are we looking for dominant range? No, just graph. Okay, so the graph is gonna look like this.